Hello, everybody. I hate to cut in at the end of that beautiful background. I can't believe how nice that looked. Hard act to follow there. My name is Eric Smalling. I'm a senior developer advocate at Sneak, and we are a developer first security scanning product company. I'm not really here to talk really about much about Sneak today, but I do want to talk to you about your containers and how they might be getting hacked into or could be getting hacked into, and more importantly, how you can stop it. If I get my slides to move, there we go. So a little bit about myself, so you know where I'm coming from. As I said, I'm a senior developer advocate at Sneak. I've been here for a little bit over a year, and I am based in the North Texas area where temperature is random lately. It was 32 the other day, and now it's going to be 80 something. So, that's how it is. I have about, give or take, 30 years of professional software enterprise development, as Java developer, C developer, all sorts of things throughout the years. The last decade or so has been kind of concentrated on consulting and mainly around CI/CD, what we might now call the DevOps tool space. And I did a good bit of work in with Docker, starting way back in the pre 1.0 days, back before we had any orchestrators or anything like that. I've recently been added to the Docker captains list. Thank you so much for the honor. And I've been consulting around Docker and Kubernetes. I actually worked at Docker for in professional services for a little bit. So that's where I come from. Enough about myself, though. Let's let's handle what's on the agenda today. So the first thing I'm going to get into is what are the challenges developers like me and you face as we start to containerize our applications, specifically around security. What's different about developing your applications in containers in that aspect? Then we're going to get into a demonstration. I'm going to show you what could happen with a real world demonstration of exploits into an application container, and we'll talk about how you could avoid that, both through some proactive steps around some of the tools built into Docker Desktop and Docker CE, and then some defense in depth things for dealing with exploits you don't even know about. And finally, we'll wrap it all up. And as we mentioned in chat, if you stick around toward the end, we're going to have some giveaways. I've got a couple of Docker shirts, a couple Sneak shirts we'll be getting out to you. So hang out till the end and see how well you can answer some Docker and Sneak trivia. So first of all, container challenges. So as developers, what's so challenging about containers? Honestly, when it comes to security, it's the increased scope of responsibility we face. So we know as developers that we have to write clean code. We need to watch out for SQL injections or poor practice, and we know that our libraries. We need to keep track of what version of our library we might be using, whether that be in Java, in your Maven POM files, or um, Node.js with your package JSON. What are you including? What are their transitive dependencies? And honestly, we have tools for helping you with that as well. But what I want to concentrate on with containers is the fact that you're now taking on a bigger role in that containers have a lot of operating system type responsibilities when it comes to securing and hardening them. You're dealing with packages, you're dealing with distributions, infrastructure level things, things like network connectivity and user IDs, file system permissions, all that kind of stuff that we all know about as a developer. You know it exists. You know that you're supposed to be using certain users and whatnot. But historically, if you've not been doing containers for a while, this has been something that your sysadmins or your security folks or networking folks have usually dictated, and you just live in their world. Now, their world is your world because the Docker files usually, often, sits right in your code base alongside your code. And while you still would talk to them about what you're doing in the Docker file, maybe it's right there, and you could make a change that could break security, and you wouldn't even know it. And that leads to, we don't have a deep expertise level necessarily in securing operating system level concerns. How do I know if I'm doing an apt-get and I'm adding a package if I'm changing my security posture? How do I know if I am using a base image of a certain version or a certain distribution, if that's good or bad? And it's just not something that we, as developers, have had to think about historically. And then finally, I mean, we live in a CI/CD world. We live in a world of iterative development and DevOps and moving things through that pipeline as fast as we can go. That velocity is something the business needs and expects. And whatever practices and tools you start to use to enhance, security at the developer's, desktop or point of view, can't be at the cost of slowing down that velocity. So we need to have tools that are and processes that enable you to be proactive as a developer rather than being something that's punitive and stop making you stop the line and figure out, well, what did I do 3 builds ago to break security? Let's talk a little bit more about, from a application developer point of view, what does my service or my app or whatever you refer to it as contain? Code, we talked about that. You got to write clean code. That's a given. Libraries, again, here's a Python app, and we're using Flask and whatever on this Python app. We need to use good libraries. We need to be able to make sure that we're not introducing vulnerabilities through open source library problems. But as I mentioned, the Docker file. This now you've got a world of like, look at this screenshot. You've got Python 3. Which Python 3? 3.1.2, 3. What version is it really? Is that a good practice to use the latest 3? Is it? Maybe it is, maybe it isn't. What about the packages you're installing with the operating system package manager, apt-get in this case? Is that the right way to do it? Is that the right package to do? What are you exposing to the final image by doing it one way or another? And all the other things that come into play there. Then on top of that, you may have infrastructure as code going on. You might have CloudFormation, or in this case, like a Terraform script that you're also having to mess with. And the granddaddy of them all is most orchestration nowadays is being done on Kubernetes. And that's an API just changed today. As I'm talking, 1.23 just went GA. So that API rolls, it's only 3 times a year now. But if you're not on top of that, if you're not sitting on the release SIGs and stuff and knowing what's going in, that can be challenging. It's enough to make you hyperventilate just to get your app up and running, regardless of making sure it's hardened for security. So that's enough slides. Let's get into that demonstration so I can kind of give you a taste of what's at risk. What could happen if you're not thinking about this stuff. So I'm going to jump over. Let's do a scenario here. Let's say we're at a company that has a Java enterprise application. That's kind of my background, so I chose that world. And we've got an old legacy app that's a WAR file that we build. That's it's the world's best to-do app. If you've ever seen a sneak demo before, we always have to-do apps for things. But this is an app that it's our moneymaker, and we don't change it much. It's kind of the cash cow, right? In this case, this is a Docker file that we made that when a couple years ago we decided to lift and shift into containers. And since the app's kind of in a maintenance phase, we don't do a lot to it other than a few bug fixes every once in a while. We haven't touched it much because if it ain't broke, don't fix it. Now, we are using a multi-stage build. If you're not familiar with that, that's where you can have multiple different from lines in your Docker file, the last of which being the actual image that gets produced, pushed, and deployed. The first from line in this example is our build. We're using a Maven 3 build. We're compiling up our WAR file basically here. And then in the actual final phase, we are starting from the official Tomcat image, the Apache Tomcat 8.5.21. Now, if you're a Java developer or Tomcat user, you probably realize that's a hella old version of Tomcat. But you know what? That's what we were using when we went to production a couple years ago. And if it ain't broke, don't fix it. We know it. This is working. Don't mess with it. So we'll see how well that works for us. Now we've got, we're just copying a few configs in here, and then we're copying artifacts from, again, if you're new to multi-stage, this is saying copy from the build stage up here. We're bringing in the WAR file and a couple other artifacts we need for our app to run. So I go over to my browser. Now I'm running this on Docker Desktop. This would work. I could be running this on EKS. I could be running wherever. I'm running this in a simple, in fact, I'll show you that. Kubernetes deployment on my Docker desktop, just because that's easy and I don't have to worry about external connectivity. And this week with AWS, that could have been a problem. But you see my pods running. One of the cool things about Docker Desktop with Kubernetes is if you have a load balancer service, it will automatically catch that and run that as your local host. So it emulates a load balancer, which is really nice. If you're doing this in kind, which is my other tool of choice on Linux, you have to kind of set up some connectivity, some binds into the machines, and This is really nice because I don't have to worry about where it's running. So I just hit localhost. There, I'm gonna refresh it to show you. There's my app. It's running. It's fine. And I'll also show you. I can go to the root context, and there's the 8521 root context. You can see that's the version we're doing. Now I'm going to metaphorically change hats here, and let's say I'm a bad actor. I'm a hacker. I am looking around the internet for exploitable things, and I somewhat specialize in Java and Tomcat exploits. This is the official Tomcat vulnerability fix release page, and you see all these version changes. And if you scroll through these, you can also there's denial of service attacks, directory traversal attacks, vulnerabilities, I should say, not attacks. And here we have a couple remote code execution ones. And what's interesting here is this one was fixed in 8.5.23. That means that anyone running an earlier version than that in the 8.5 family possibly is vulnerable. If I go in and look at the CVE, I'm pulling up the Snyk vulnerability database version of the CVE. This is kind of like MITRE. We add a few extra niceties to it, but it's the same kind of information. And I could dig into this. I could figure out what it is that's vulnerable. I could create a hack. But lucky for me, because this is kind of old, there's a lot of information that's been gathered on this. And there's a couple exploit DB links here. I'm going to take a look at one. This has a Python script. And without even really being I do a bit of Python, but I wouldn't call myself an expert. But I could look through here and I could see what's happening, and I could see what they're doing. They're building up a post that will inject a arbitrary JSP into the server. So all I did is I took this script, copied it locally, and I actually have a container I run it in, but it's under an alias, and I call it check. So there's two functions to it actually. There's a check to see if you are vulnerable, and then there's a pwn to see to actually exploit it. And you imagine this would be in a real world scenario, something like this would be in a war dialers type thing where they're looking for what looks like Apache Tomcat endpoints on the internet, and they find them and they run this against it to see is it vulnerable or not. So in this case, that's my local desktop IP, and it hit it, and it says yes, it's vulnerable, and it actually put a little POC JSP out there. So let's go in here. I'm going to put JSP, and you see a bunch of A's. Now, a bunch of A's on a page isn't really nefarious very much, except for the fact that that JSP wasn't there a minute ago. And now it is, and somebody remote to this Tomcat server has put a new JSP on there. And you imagine what else you could do in a JSP. Let me go back to the script. I'm going to run the other half of it, the pwn part. Go back to my browser and POC the PWN. And it's not going to work, of course, because what did I do wrong? Live demos, folks. There we go. I just typed it wrong, apparently. A little form. That's kind of nice. Let's see what is in this form. I can type a Linux command, and it's running it. This is a remote code execution, arbitrary code execution. I'm running a shell. So the JSP that was injected basically is doing a system call, and it's running something in that Tomcat environment. In fact, I can pull my environment variables. There's a lot of stuff you could do in here, but this is interesting because it's one of the first places I would look if I was doing this, because I could see some evidence of what I'm dealing with. I see a bunch of Kubernetes variables that tells me, I am probably running in a pod on a Kubernetes cluster. You can actually, if you know anything about Kubernetes, there's the Kubernetes port. That is the API server's internal address. So if I wanted to, maybe I could start trying to pick at the control plane of my cluster and see if I could break into the cluster and get control of things and start other things up using the Kubernetes API. But anyway, but that tells me. But what I get from here, really, the most important thing is I'm probably in a container, which wow, that's a sandbox, right? I can't do much. Well, maybe, except that I've written that container. That's kind of cool. I wonder if I have write access to things. Let's try touch. Something somewhere I shouldn't be able to. LXLTR, Etsy, foo. Oops, well, there it is. I meant to type LXLTR, Etsy, but There it is. You can see the dates difference. This, I just created that foo file in the etc directory in the containers file system. That's interesting. That tells me I have a read-write file system. That means I can start mutating things. And there is, I'm going to go off script here. This is always dangerous to go off script on your demonstrations. But I have, copying something from another monitor real quick. I have something I was playing with earlier. I'm hoping this is going to work for you because it's kind of cool. I'm going to do a wget. In fact, let's just make sure I have wget. Google.com. Oops. Let's just do this. Let's see if I have it. Oh, I have it. So I have wget. I kind of knew that. But let's do a wget, quiet it down. We're going to output to temp, I don't know, foo.shell. I'm going to paste this little URL I made. And if we cat, that. Oh, I went off script, so I got to remember, yeah, put it in temp. So if I do cat temp foo.shell, told you, shouldn't be going off script. It's terrible. Okay. I came in 0. What I was going to show you is you could have any shell script you want. I'm doing wget incorrectly, apparently. Oh, I know what I did. Hold on. I'm going to make this work, guys. Oh, temp shell and quiet paste. Now we'll do cat temp shell. There we go. Now I'm going to run. Temp shell. I'm going to wait a second. That is going out and getting a little tool I like called tmate. On temp again. Out file, let's cat that out file. Temp tmate dot out. And I'm going to copy that. Paste that here. You can only see my browser. That should be fine, Julian. Do you see the shell in my browser? Okay, good. Yeah, so what I'm doing, tmate is an interesting project and tool that allows you to start up. It's made for team pairing, right? So I could run this and I could do paired programming with somebody, and we both have a tmux into the same shell. You can also run it though with their service, which gives you free access. I could run my own server if I wanted to, but I'm using theirs. I can now do anything I want to because I'm root in a read-write container, and I'm not going to belabor this. I would probably, if I was most hackers, I would have actually pulled a script down that starts crypto mining now. Use all the CPU I can get. So you can see that this, I've set up a beachhead. I could install Nmap. I could start poking around your network, see what else is installed on here. So that being said, I'm going to get out of that. And I'm actually, before, I'm going to do a delete on that pod because you all saw that URL and you could be getting in there and doing whatever you want. So it's gone now. It should be restarted into its stable position. So honestly, when that happened, a bunch of bells and whistles should be going off in your production department with intrusion detection or something else. Maybe you have Falco running that's watching for things that shouldn't be going. That's great from a reactive point of view, and maybe that would have caught me and stopped me. But as a developer, wouldn't it be better if I could proactively had known that remote code execution vulnerability or all the other ones that you saw on that list existed and headed them off before I even shipped it? And that is where scanning tools come in. So Docker scan, pull my image list here. It was added about a year ago, I guess, give or take, to Docker Desktop. And then this past spring, it was added to Docker CE. And what it does is it uses the rsneak container scanner on the back end to do a container vulnerability scan right there on your machine. And if I do Docker scan, I'm going to feed it I know which one I did. It's this one on the legacy tag. Oops, I forgot an argument. I like to feed it the file equals Docker file. That gives it a little hinting. So it's going to scan that image, and it knows that that's the Docker file that built it. Um, the question sent to yes. So there is our vulnerability database is a service that the Snyk scanner uses. So it's locally going through and it's going through all the layers of the image, looking at the file system, looking at what packages are installed, determining from fingerprints what the base image is, as well as the Docker file that we've linked to it. And it's going to send that kind of information off and start querying our database to say, hey, I've got this. Is there anything vulnerable? Back and forth. And finally, when it comes back, you'll see we get the long list of all these vulnerabilities. But actually the more interesting thing, I think, in the output is that it's going to say, hey, we see you're using a really old version of Tomcat at 8.5.21, which has a lot of vulnerabilities. If you would do a minor upgrade, just go to the, I think 72 is the latest one, you would drop your vulnerability counts drastically. And generally, if you're on the latest official image of any kind, it's very rare to see zero vulnerabilities. We'll get to the alternatives here in a second. But these are vulnerabilities that there generally aren't any fixes for yet. So at this point, let's say I'm junior developer. I don't know much about any of this, but I run the tool because it's what we do every day. We just run this before we do our unit testing. And I'm thinking, oh crap, that's a lot. That looks bad. And I pull my architect, maybe my security admin over and say, hey, look, what do we see here? And we look at this and we say, okay, well, this would be fine. We should do this and test it and see if it works. That would get us past a lot of these problems. Not even knowing, exactly, not even looking at what's above. We know this is better than that. We could go to 10, which is a minor upgrade, but it really doesn't bind us anything. And I'm pretty sure our app won't run on 10 because there's some SDK differences and whatever. If we wanted to go to 0, we could go to Amazon's Corretto JVM. But that's a bigger change than we're ready to take on right now. That's trusting a whole nother vendor, and we're not quite ready for that. So let's go ahead and take the smaller update that we know our application will run on, and we'll do that in this build, and we'll put on the back burner to investigate what are the remaining vulnerabilities and how can we compensate for them and whatever. Now, I'm not gonna. We only have limited time. I'm not going to go through building and redeploying on this and to show you that it doesn't work. You have to trust me; it doesn't work, or the exploit's no longer there. Let me jump back over here. What about exploitation? Sorry, I'm looking at your question. What version has scan has an option? I'm running Docker desktop to, it says scan is not a Docker command. For Docker version, it should be, I'm going to table that question and come back to it. It should be any version of Docker desktop that's been released since, I want to say November, maybe December of last year, and Docker CE since about early summer, June, maybe May. But I'll come back to that. Oh, correct. Yes, Docker Desktop is a product. It is the Docker for Windows and Mac. They do not have a Linux desktop yet, but Docker CE for Linux, as of, like I said, I can't remember the exact version number, but it's somewhere in the June timeframe, June 21. So it would be newer than the 20 builds. It does have it. And it is the Docker CE you would get from the Docker app repos or Yum repos or whatever. So what about issues with, let's pretend that remote code execution was a 0-day. It wasn't something that was in an old version of Tomcat. It's not something that proactively a vulnerability scanner might not have found it because it's not been found yet, right? There are some practices you can put in place to provide defense in depth, to provide, make it harder for the hacker. And there's 3 main areas I touch on with this usually, and that's images, runtime, and Kubernetes. So in the image point of view, you want to minimize your footprint. The whole point of multi-stage really is so that last image doesn't have, like, for instance, when we looked at that, it didn't have Maven. You don't want that going out to production. You don't want your source code going out to production. You want to minimize the footprint so that you're not adding binaries. For instance, I had wget at my disposal. I had curl. I had a whole bunch of stuff at my disposal to use that my application doesn't need. So if your app doesn't need it, don't pick an image that has it, right? So that there are slimmer versions of the Tomcat images that you could look at and might work for you that don't have some of those tools. In fact, I was at a meetup recently where the intrusion detection stuff was being talked about, and they used a term called living off the land. And that means, don't install something on a machine if you can use tools that already exist that are provided to you by that machine. Because as soon as you install something new, that could trip a tripwire kind of a sensor or some kind of intrusion detection. So don't give them a bat to hit you over the head with, basically. Layer housekeeping. You need to kind of understand how layers work in Docker. They are immutable, but if you in your Docker file, if you just removed curl in that same Tomcat image, yes, to the running container, it wouldn't be visible anymore. But if there was another exploit that got me access to the host file system, for instance, somebody bind mounted that/var, which would be horrible, and you should never bind mount host file systems in your containers. But if they did, var lib docker layers, I could get in and I could find executables that you think you hid, and they're still there. As far as build strategies, multi-stage is one of my favorite tools in the world. It works great for this exact discussion. There are other tools you could be looking at. If you're a Java shop, you could look at Jib. This builds Docker OCI compatible images without even needing a container runtime or a build tool at all. It's a self-contained 100% Java image builder. I blogged about that. If you go look at the Snyk blogs, you can search for Jib, you can find it. Make sure your builds are repeatable. So by choosing a tag on your from that is specific, then every time that commit gets built, you should be getting the same base image. If you choose a non-specific or an inspecific one like Tomcat 8 or Tomcat 8.5, that's a mutable moving target. It's always going to be the latest one of those, or the latest tag is a great example. That's great for investigational, experimentational work on your desktop and to see how do I run with the latest. But you always want what comes out of a given commit in your Git cluster, your whatever version control, to produce to get the image you think it's going to get, right? You don't want a moving target at that point. You want to pin to a version, but be ready to move to the next version. It does not download the database. It is always using the most up-to-date online database. The Snyk database is it's a service. So as far as on-prem solutions, if you can't hit ours, we have products for that. You could go onto our site and look into it. I'm in DevRel. I don't deal with any of our paid stuff, so I only deal with the free stuff. Everything I'm showing today is in our free tier. Yeah. So no, it does not offload the image off-prem. It basically builds a manifest of it and uses that to query the database. There is a way you could say monitor, which will take that manifest, ship it up to your account, your free account in Snyk, and it'll continually monitor against that manifest. But it's not really taking your image completely. That would be pretty heavyweight, especially since a lot of images are pretty fat. Secure supply chain. That entire conferences are being built around secure supply chain. You heard SJ talk about it this morning about Notary V2 and all the things that are involved in that. But as a bullet here, what I want to say is make sure you know where your images come from and how they were built. Never deploy an image that was built by anything other than your automation. Eric Smalling's image he built on his laptop should never deploy to anywhere important because you have no idea really what's in that image. You're trusting that when I logged in and pushed it to the registry, that I can be trusted. Nobody can be trusted. You need to have automation, and do look at some of the there's a lot of movement right now in this field around signing images and signing building a chain of trust. Whole talks, conferences on that. Getting into runtime concerns. I was root in that container. That gave me elevated privileges in the container. I could do an apt-get. I could do I could edit files that need UID 0 access to do it. So if you don't need to be root, don't be root. Most business applications at least don't need that, and you should be setting a less privileged user to run your process as. Privileged containers, that's a whole nother thing. That's never run a container privilege. Nobody needs to run a container privilege unless you're doing something really, really low level, like you're writing monitoring applications for Kubernetes clusters, or your network CNI plugins for Kubernetes. And privilege gives you access to the host, the server outside the containers devices. You could mount volumes. You're pretty much root on the box if you give a container the process privilege. Linux capabilities are similar. Functionality allows a process to have temporary elevated privilege to call certain system calls. And so, like, ping needs an elevated netcap add to do ICMP packet creation. So it needs that capability. Most business applications, I shouldn't say most, many don't need any Linux capabilities. They're just doing things that are businessy. And you can probably deny all Linux capabilities and be just fine. There's also a lot of blogs out there talking about how to determine if your application needs what capabilities it needs. The Docker team and the Containerd team have done a good job of narrowing the default set of capabilities down, but again, you probably don't need even that much. Read only. You can run your containers read only, a read only root file system. And by doing that, it makes it immutable. And a lot of the stuff you saw me do would be very difficult, if not impossible, to do if I can't mutate the file system. Just by simply saying -- read only, or if you're in Kubernetes, setting the security context to do that, will solve a lot of problems and make you a much harder target. And a hacker looking for an easy target will see that and say, I'm not going to worry about, I'm not going to mess with that. I'm going to go to somebody else. So that's another key thing. Allows you to be more 12-factor because you're immutable. There are challenges to doing that with some apps, but I think they're worth trying to tackle. And then, just like I said in the prior one, secure supply chain, know where your sources are. Don't just take images randomly from the internet and then just use them. Make sure you vet them. Make sure that you put them into your own local registries and know where they come from and have access to them. And looking at the clock, okay, I think I'm doing okay. Kubernetes things you should be using, should be doing. Secrets. If you don't already have some kind of secret management system like CyberArk or HashiCorp Vault or something that your application uses, Kubernetes secrets are great. However, and I can't give you a tutorial on how to work them, but make sure if you are using them, you're using RBAC with them, because that's the whole point, is to make sure you can secure them to only certain service accounts or whatever needs them. And make sure that your cluster operators are encrypting them at rest. The etcd database they're stored in, by default, if you just do a kubeadmin, start up a container by DIY, they're not. They're just base64 encoded, and anybody that hacks in and gets access to your API, control plane API, or with elevated privileges, can read them, and they're not encrypted. So make sure that that's happening. Use RBAC, use role-based access control. It is can be a little challenging to learn at first, but it is very valuable, and you should be using it. Security context. These are the specifications on pods and containers that Kubernetes gives you that implement a lot of the things I talked about on the prior slide and more. There's a list of links at the ends of these slides that we actually, my buddy Matt and I wrote a cheat sheet, goes over a lot of the security context and good settings to use for those. I'll be sending these slides out by Twitter afterwards. So network policy is awesome, and if you're in Kubernetes, you should be using it. It's really not as complicated as a lot of people think it is. It's simply a way of specifying how pods can or can't talk to each other on the network. And I'm a fan of zero trust, which is you bring up the application and no pods are allowed to talk to each other at all, except what I explicitly put in the allow lists. So front end can talk to back end on this TCP port, but back end can't call back up. Things like that. If you do it, make sure you open up DNS for everybody, because Kubernetes uses DNS for service discovery, and you can be up a creek if you don't do that. And then all of this stuff can be enforced at deployment time with tools like OPA Gatekeeper, Kyverno. Pod security policy is kind of the legacy way to implement a lot of the security context things, but that is deprecated. It's being replaced with pod security admission, which I believe as of today is in beta. But make sure you're doing something. make sure your cluster operators have implemented something like this, because it's great. Because as a developer, if I don't know, let's say I deploy something and I put in a privileged pod because I was hacking around to get it to work. I'll be able to deploy that often to my sandbox clusters and not know that I'm not supposed to do that until I get to a later cluster where they've implemented Gatekeeper, and all of a sudden it breaks the pipeline because it can't deploy to the QA cluster or something. If you use these tools uniformly, I would have known immediately when I typed kubectl apply, I would have got an error back that said you can't run privileged, and I would have known immediately. Fast feedback, right? You go, well, we're always going for fast feedback loops. So my key takeaways, I just said fast feedback loops. So you want to have fast feedback loops, just like your unit tests in your code. You want to be able to find out quickly that you have problems, and having a scanner like Docker Scan that runs in just a minute or two on your local machine can rip through your image and let you know about any known vulnerabilities. Um, you want that tool to be proactive. So no matter what tool you use, if you don't use our tool or Docker's tool, make sure the tool you use gives you proactive information, not just a spreadsheet of CVEs. You want to know, oh, there's fixes to these things. And I'll get to that question in a second. And then finally, practice defense in depth. There are things that are not known that if you make it harder for hackers to get to you, it will be harder for them to attack you. So, AO, just hold on to that question for a second. I want to make sure we get to the trivia because I know people have been hanging out for it. First Docker shirt giveaway is going to be, this is all trivial stuff, so you might be easy, might be hard. Everybody knows the blue whale. That's Moby. That's too easy. What's the pink whale's name? First chatter to tell me the pink whale's name qualifies for a shirt. And I'm going to hang for a second. And I'll go on to the second one. I'm going to write that in the. Oh, Michael Rodriguez got it immediately. Molly, that is right. So the second one. So everyone knows the whales, but there's also a turtle, a tortoise. Oh my gosh, Julian's too fast. Oh, well, both Docker shirts are claimed. Michael Rodriguez and Julian, I will make sure we get your names to the appropriate people. So I've got a couple Snyk shirts. Yes, I got to meet Gordon when I worked at the office years ago. So he's in a reserve, right? We found out it's a she, and she is in a reserve. Okay, next, Snyk shirts. So 2 trivia questions, 1 picture. What's our mascot's name? The dog. Doberman Pinscher. Does anyone know? No, not Labrador. I'm going to throw out the second one, the dog. That's probably the most common. Patch, Fritz, yes! Fritz got it. Nice. Okay, last one. So Fritz will get a Snyk shirt, and I will get with you later to get your details to get that to you. So last one. What does Snyk stand for? It's an acronym. And yes, it is pronounced sneak. Don't believe any of my UK colleagues who say snick. Coming straight from our founder, it is sneak. Oh, Brad knows it. So now you know. That is true. That is what the acronym stands for. Okay, I'm going to leave this up for a second. And like I said, I will be posting these slides with all of these links to my Twitter, which is at the bottom left there, Eric Smalling, all run together. I'll probably post them to LinkedIn as well if you're on there. The question that was asked earlier about the manifest sense, it's not a manifest.json. Don't take it that literally. What I'm saying is that our tool collects information about the apt packages and everything else that's in the image, the base image and all that kind of stuff, and it then queries our database based on that information. If you run the monitor side of our tool, which would be if you use the actual Snyk tool, not the Docker one, if you actually downloaded our Snyk CLI and use that, or if you logged into the web interface and set things up, you can set it up to say, hey, take this bundle of information I know about this image and daily let me know if any new vulnerabilities come up for it. And then it'll email you every time, every 24 hours it'll check and say, oh, a new vulnerability came up in the image you told me about the other day. Our tool also allows you to do that with like your GitHub repo. You can say, hey, attach to here, and then the Docker file in there. do a static analysis of that and let me know if anything in there ever becomes vulnerable. And it'll continually watch that like a CI server kind of, and if any new vulnerabilities come up, it'll do. So hope that answers your question. It's not the package manifest like you would have with the JSON with a node file, although we have scanners for that too, but it's still the same idea. It's the metadata about it. And it is 12:50. I think I am close to or at my end of time. I am going to get back to you. Let's see, I want to make sure I got the names right. We've got Michael Rodriguez and Julian. I am not going to try Julian M with Docker shirts. And I have Fritz R and Brad South. I will be getting back to you with information about Sneak shirts. We'll use the chat here to. That's okay. I don't want to butcher it. I feel bad when I butcher people's names. So I just want to thank you all. If there's any other questions, feel free to DM me or hit me up publicly on Twitter or LinkedIn. I'll hang out here for a bit in the chat if you want to hit me locally here too. But thanks again. And I'm going to turn my camera off so the next person can get in here when it's their time.